Okay, everybody. So we're going to do a quick review of what we've gone over, and also we are going to go through each one of our questions. So the notes we just took today, okay, are review, right, of your basic trig functions. So if we have a triangle looks like this with angle A, B, and C, side A would be over here on the opposite. We would say side is opposite of A, but it's also what's considered adjacent to B, which is important for when we do our trig functions, okay? This down here is the side opposite of B, and it's also what's called adjacent to A. So depending on what angle you're looking at, if it's A, that's opposite, adjacent. If it's B, down here would be the opposite, and to the side over here would be adjacent. And then last but not least, the hypotenuse is always that diagonal type angle. All right. Okay, and if you can remember this, SOHCAHTOA, your sine is opposite divided by hypotenuse, your cosine is adjacent divided by hypotenuse, and your tangent is your opposite divided by adjacent. Okay, that looks like this. Sine of your angle is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. And then you have your three other functions. Your cotangent, COT, is the upside down version of tangent, so it's adjacent over opposite. Your secant is the upside down cosine, so that's hypotenuse over adjacent. And then cosecant is the opposite or the upside down adjacent, so that would be hypotenuse. Wait, cosecant is the opposite sine. I think I misspoke. Cosecant is the opposite sine, so that's hypotenuse over opposite. And then today we're talking about cofunctions. Okay, cofunctions are sine and cosine, tangent and cotangent, and secant and cosecant. What's so important about cofunctions is this. Okay, the cofunction theorem says the trigonometric function of any angle is equal to the cofunction of its complement. So what that would look like is sine of 30 degrees and cosine of 60 degrees are equal. So the sine of 30 and cosine of 60 are equal. Why? Because sine and cosine are cofunctions. 30 and 60 are complements, right? They add up to 90 degrees. Therefore, those values would be equal. So the tangent of 10 degrees is equal to the cotangent of 80 because tan and cotangent are cofunctions and 10 and 80 are complements because they add up to 90. The third example for this would be the secant and cosecant are equal if they're both 45 because secant and cosecant are cofunctions and 45 plus 45 adds up to 90. All right, that brings us to this basic, what's called a basic trig identity that says the sine of any angle squared plus a cosine of that same angle but squared, which they write the squared above the sine and cosine like this. It's a sine squared of this angle, it's cosine squared of this angle. So it means find the value of that sine, okay, that fraction, whatever, and then square that value. Okay, as long as those angles are the same and you square that number plus square that number, they say it always adds up to 1. Okay, it's called an identity. It's just something that always happens. So sine squared theta plus cosine squared, sine squared of 30 plus the cosine squared of 30 is going to add up to 1. Okay, those numbers have to be the same. Here's a basic trig table. Okay, it just goes over 30, 45, and 60. And the trick that I always use is I start with this order here, sine, cosine, tangent, and then I do 30, 45, 60. So this order with those numbers, 30, 45, 60. Those kind of come back from those special triangles, right? The 45, 45, 90, and the 30, 60, 90. So those famous type angles. It goes 1, 2, and 3, which means the square root of 1 divided by 2, the square root of 2 divided by 2, and the square root of 3 all divided by 2. The square root of 1 is just 1. So that's the pattern. Okay, this is the pattern, and it's really cool how this works out. Cosine is just the backwards version of it. Okay, so it goes, instead of 1 over 2, it's 1 over 2 is on this far side. Square root of 2, well, that's just over here in the middle also. Square root of 3 divided by 2, well, that's going to be over here on the left side. So you see how it kind of goes backwards. Tangent, well, that's just sine divided by cosine. So this divided by this, when it's simplified, looks like this, square root of 3 over 3. Tangent, anything divided by itself is just 1. And then square root of 3 divided by 2 divided by 1 over 2. When you simplify, it's just the square root of 3. Tangent and cotangent are backwards like this. And then secant and cosecant are kind of the same as sine and cosine, and they're backwards of each other. And then what you'll see with secant is either 2 divided by the square root of 3, or sometimes you'll see it kind of in a quote-unquote simplified version where the square root's on top, and they call it 2 times the square root of 3 over 3. Secant of 45 is square root of 2, and the secant of 60 is just 2. Okay, and then what happens with the cosecant is it's just backwards. Okay, it's just this number is on over here, this number is here, and that number is over there. Okay, so how do you use this? Is you say something like, well, hey, what's the sine of 60 degrees? Without a calculator, it should just be sine of 60 is square root of 3 over 2. If they want this as a decimal, well, you can just take, you can just go here to a calculator and say something like, well, what's the sine of 60? There's one way to do it. You could have also said square root of 3. Okay, divide, so make sure it's the square root's on top only, and that's divided by 2. Okay, see how it's the same number, exact same number. So any way you look at it, it should be the same. Okay, and then last but not least, if it's not 30, 45, or 60, then you're forced to use a calculator. Okay, you can't use the table anymore. You just have to use the calculator. And it's very common to round it to 3 places, okay? All right. So looking at this week's stuff, the first question says B is 24 and C is 25. So what you should do, what you need to do, after I make sure that's all zoomed in properly, what you should do for these problems is first figure out what you're missing, okay? After you figure out what you're missing, then you can do the whole thing. All right, so I like to draw it out, and then I like to figure out my missing pieces. So this is my number 1, and it looks something like this. Now, they don't give you necessarily the exact looking triangle. They just give you a generic triangle. Okay, and they say A is over here, B is over here, and C is over here. So you see how for mine, maybe yours might be a little bit different, but for mine, it says sine, cosine, tangent, cotangent, secant, cosecant of A. So that means I'm looking at this one. That means this is my adjacent. This is my opposite, because it's always opposite this way. And then this diagonal is always the hypotenuse, okay? So if it's at angle B, I would switch my opposite and adjacent. So it says here B equals 24 and C equals to 25. So this is 24 and this is 25, okay? Which I could use Pythagorean theorem calculator. I believe this is a Pythagorean triple. I think it's 12 question mark. Let's see here. So C is 25 and B is 24. What does A equal? Calculate it, and it says here A equals 7. Why did I think it was 12? So when I do the Pythagorean theorem calculator, that's going to equal just 7. Okay, you're going to have to do that first for this problem. So draw it out, use a calculator, or do the Pythagorean theorem. Okay, that'd be A squared plus B squared is C squared. So A squared plus 24 squared equals 25 squared, and you can solve it from there. I recommend just use a calculator so you can move on. So for this one, it says find the sine of A, find the cosine of A, the tangent of A, and then find the cotangent of A, the secant of A, and the cosecant of A. So as a reminder, it's opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And then they're going to want us to do the cotangent, which is this one upside down. Secant is cosine upside down. And then cosecant is the sine upside down. All right. So now it's just basically set up the equations and move on. Or set up the fractions and move on. So it says opposite over hypotenuse. So sine of A is going to be 7 over 25. Cosine is adjacent over hypotenuse, so 24 over 25. Tangent is opposite over adjacent, so it's 7 over 24. And then I would just keep going down this, okay? Cotangent's just that upside down. Secant is the cosine, but upside down. And cosecant is the sine, but upside down. So I'll just type that in. And the sine is going to be 7/25. Cosine is 24/25. And 7/24. This is going to be 27. 4. Cosecant would be 25/7. Hit submit. 100%. Okay. Now what I could do, okay, let me get a similar question. Let's see if it is much different. Okay. This says sine of A again, and it's got new numbers, 12 and 13. Let's just go ahead and move on to the next question. Okay. Just for time, I'm going to go through each one. If you guys need to review, you guys can watch this video. Okay. Okay. Question 2. Question 2 is very similar, but this time it has a square root. So you're going to have to use the Pythagorean theorem again. It's just going to have a square root in your answer. So let's set it up again. This is A, B, and C. Okay, this is A, B, and C. So sine of A, A equals 1, and B equals the square root of 24. So that would be, your C value would equal 5. I'm going to guess that. I'm going to guess that because 1 squared plus the square root of 24 squared is going to equal 25. The square root of 25 is just, let's see here. Oops. It should just be 5. Ready for this? Let's see here. My C value equals 5. Yeah. So A is equal to 1. B is equal to the square root of 24. And this is going to be just 5 by itself. Okay. So use this calculator, okay, if you need help. So we're going to do the same thing. Sine of A, well, that would be opposite over hypotenuse. So it'd be 1 over 5. The cosine of A, well, that would be the square root of 24 divided by 5. The tangent of A would be 1 over the square root of 24. And you could leave it just like that. The next one's going to be the cotangent of A, which is square root of 24 divided by 1. Anything divided by 1 is just that thing. After cotangent, it goes back to secant of A, and that would be this one upside down. So 5 divided by the square root of 24. And then the cosecant of A is this upside down, 5 divided by 1, which is just going to be 5. Let's type that in and let's double check. Sure, it's the square root's only with the top of that one. Dividing that one by 1. Divided by 1 is just 5. 100%. So let's see. Did they actually? Yes, they put that over 1. That's cool. All right. So 1 and 2 are pretty much the same thing, just 2 has a square root with it. Okay. Let's see the next. Whoops, that's not what I wanted. Let's go to question 3. So it says find the exact value for the following. This is where you want to use that table. So have your notes, have that table written. It says find the exact value for the cosecant of 30. Cosecant 30 is just 2. That's it. Let's get a similar question. Let's see what that looks like. Find the exact value for the following. Secant of 60. All right, secant of 60. We got secant, we got 60. It's just 2 again. Okay, let's try another one. Cotangent of 45. Cotangent 45 is just 1. That's how you do these ones. Okay, just look at this table. Cosecant of 45 says radical 2. So square root of 2. Okay, they want the exact answer, not the rounded answer. Next question. This says simplify the expression by first subtracting values from the table of exact values and simplifying the resulting expression. It's always going to equal 1. Okay. That's a sine squared of 60. So that's radical 3 over 2. Radical 3 divided by 2. And then they say 2 square root that. And then they want you to add that to the same other one, squared. And that's going to equal, see over here, equals 1 every single time. Okay, every time. Similar question. Similar question. It just doesn't matter. Your question 4 is going to be probably the same exact thing. Okay, 45 this time. Guess what? It does not matter. It's going to equal 1 every single time. Okay. Question 5. This one says to use a calculator and find and run it to 3 decimal places. So cosine of 45, you can just go here. Cosine 45 is square root of 2 divided by 2. So you have 2 options. You can either just say the square root of 2, divide that by 2. So make sure it looks like this and tells you 0.707. Or you could actually type it in. This says cosine 45. So you can type in cosine 45. Whoops. Just say cosine 45. You can do the same thing. It says 0.707. Okay, they'll give you the same answer. So 0.707. Similar question. Sine of 60. Radical 3 over 2. So you can type in sine of 60. Or you can say the square root of 3. Divide that by 2. And you get the same answer, 0.866. Okay, that's those 5 questions for the week. Hopefully it makes some sense to you guys. Please, pretty please, if you have questions, have those questions ready to go on Wednesday. Okay. All right. I'm going to go ahead and stop the video.